Now we got our ellipses. Look at these ellipses. You see how he kind of looks like a circle? He kind of does, huh? Except the A and the B, the two denominators are not the same. It's not r squared and r squared like our circle. And it's important to note with the ellipses that A is greater than B. Very, very important. They're not equal. If they were equal, guys, this would not be an ellipse. It would be a circle. Notice also, there's no coefficient in front of the x. There's no coefficient in front of the y. If there was, you got to get rid of them. Okay, so how do you graph these dudes? What is this A business? What is this B? And what is this C? What? There's a C? Yeah, right there. You see, this is how they all relate to each other. That's the equation for it. Okay, so how do we graph these dogs? Well, we got to start at the center. That's your HK. In this case, our HK is our origin. And because this is a vertical ellipse, we're going to have to go up to our vertice up there and then down to the vertice down here. That means our focus point is going to be right there and our other focus point is going to be right there. They all are on the major axis. The major axis? Yeah, the major axis is the one that has the vertices on it. The major axis for the ellipse is always the bigger axis. There's another axis? Yes, there's another axis. See, check this out. There's a C, V, CV. I'm going to call these co-vertices. This is your minor axis. Oh, major, minor axis. So this is how your ellipse would look. There's a couple important markings here. Let's say the distance from V to the center, that is your A. All right? And then the distance from the F down to your center, that is your C. The distance from the center over to the co-vertice, that is your B. So which letter makes up the major axis? That's right, the A's. Two A's, actually. So this A and this A would make up the major axis. So every major axis equals 2A for an ellipse. We'll say MA stands for major axis equals 2A. So what is the minor axis? Oh man, I can't use the M again. Let's go minor. The minor axis equals 2B. Now I want to talk about the coordinates of the vertex really quick. Look at HK. We're going to start right here. And if I start right here at HK and go up to the vertex, which value is changing? The H or the K? The K, the Y value. The Y value is changing because we're going up. The H stays the same. How much are we changing the K value by? We're changing it by A. So we go from the center up to the vertex, so we'd have to add A to the K. That's why right here we have a K plus A. We also have to go down A also, so we K minus A. And that's how you get the two vertices for our ellipse. Now let's look at the horizontal ellipse. The horizontal ellipse goes from here to here. Those are your vertices. Here's my center. That means the foci are right here and right here. Our critical, or not critical, our co-vertices are right there and right there. And then you can connect everything. Oh, okay. And everything's the same. The distance from the center to the vertex is still A, but now it's horizontal. The distance from the center to the co-vertice is still B, but now it's vertical. And the distance from the center to the focus is C. Now, I want to ask you guys this question and see if you guys can tell me. How do you know which one is vertical and which one is horizontal? Like if you were to see this equation all by himself, how do you know he's the vertical one? If you were to see this equation all by himself, how do you know he's the horizontal one? So because you know that A squared will always be bigger, that number is the number that's going to tell you if it's horizontal or vertical. So if the bigger number is underneath the Y value, then you know it's vertical. If the bigger number is underneath the X, then you know it's horizontal. Okay, and don't forget this guy. This guy right here relates the A, B, and the C, and it's minus. See down here, it's plus. So it's slightly different. So look down here. How do you know which of these equations is vertical and which one's horizontal? This time, it doesn't have to do with the A and the B. It has to do with something else. Talk to your neighbors. See if you guys can notice a difference between the two. Positive or negative? Okay, see, look at these. This fraction right here, is this positive or negative? That's a positive fraction. And this fraction right here, is that a positive or negative fraction? Negative. Which one is positive, the x or the y fraction? The y fraction. And guess what? This one's vertical. Look at over here. Which one's positive, the x or the y fraction? The x. And that one's horizontal. So that's what matters. That's what matters. That's how you tell. Whichever one's positive, that is where the major axis will be found. Now, in this case, for the hyperbola, A is not always greater than the B. So make note of that. But the A is always a part of the positive fraction. We can switch the order of these two fractions right here. Like keep the negative on this one, and it stays the same. The positive fraction is the one that determines whether you're vertical or horizontal. So how does it look? How does a vertical hyperbola look? Well, the HK is still your center. Oh, I'm glad that doesn't change. Something stays consistent. And then the A gives you the distance to the vertex. Hey, that's just like the ellipse. You're right. Okay, so here's your vertex right here, and here's your vertex right here. What is the distance of this? A. Then you have these points right here. Now, the book doesn't really say anything about these points. It doesn't call them co-vertices like I am calling them right now. But I think it's helpful to do so. Okay, the distance right here is B. So that's your A and your B. Your A and your B give you the vertices and the co-vertices just like the ellipse. What? That's kind of cool, huh? It makes it easier to remember. Now I'm going to draw this box thing right here. What's the purpose of that box thing? I'll tell you the purpose of this box thing in a second. Hold on. Just draw this box thing. The reason why I draw that box thing is because of these points. You see this point right here, and this point right here, and this point right here, and this point right here? We need those points because those points tell us where the asymptotes go. So you draw asymptotes through those points. Can you guys tell me the coordinates of this one point right here? Its value would be the distance of this. And what is the distance of this? It is B, people. We already did it. So this is B. The y value would be the distance right here. And what is that distance? A. Oh. And using that, you can find each of these also. Okay. Over here, guys, I have the asymptote equations. These equations only work if you're centered at the origin. If you're not centered at the origin, you gotta use your points to find the equation of an asymptote. But where are the parabolas for the hyperbola? They're right here. Make sure you go towards the asymptotes because they are attracted to asymptotes. Okay? Yep. All curves are attracted to asymptotes. But what about my focus? It's right here. Focus is right there and right there. What is a distance? What is a distance from the center to the focus going to be? Do you guys know? From the center all the way to the focus, that distance is going to be C. And so it's still kind of the same as up here because the distance from the center to the focus is also C. So how would it look if it's horizontal? First, let's graph our center. Then we're going to go out to our vertex right there. Actually, let's not put them that far out. Let's put them closer. And then put this vertex right there. And then my focus is going to be right there. And my other focus is going to be right there. Remember, we used the A to get from here to here. And we used the C to go all the way to the F. And then we use the B to make the other side so we can draw our box. We need our box so we can draw our asymptotes. And our asymptotes are going to go like this, straight through the corners of our box, our asymptote box, our asymptotic box. I don't know what you call it. Okay, and then we have our parabolas. Oh, so pretty. Not a formula guide now, guys. I fixed those, made them dots. But I did give all these like formula things to you guys. I think this is confusing if you're not a formula person. I like to just think, okay, the A always takes me to my vertex, my C always takes me to my focus, and my B goes the opposite direction. Those are my co-vertices. And then I remember these equations because that's really helpful. That's all I got.